Welcome, guys. Today I'll be treating question indices, on indices, on indices. In my first video, which is the part 1 of this video, I treat all the laws of indices. So if you have not watched my video, the part 1 of this particular indices, please go back to it and watch my part 1 on law of indices, because I explain all the law of indices to the core. Now, in today's lesson, I'll be using those laws to solve questions today relating to indices. So, very simple and clear. So, the first question I have here is I have 3x times 9 over 27 s plus 1. So let's look at this particular question. Solution. Now, if you observe here, you will notice that we have 3 here, we have 9 here, we have 27 here. So it means that this 3, we can change all these base to 3. So everything will be in what? Base 3. Now this one is already in base 3. So write it back. 3 raised to the power x times, if we have 3 raised to the power 2 to give us 9, because 3 times 2 will give us what? 9. So we can replace this one with 3 square. We can write 3 square, then we input the power back, s minus 1 over 27 can be written as 3 raised to the power 3, because 3 times 3 9, 9 times 3 we have what? 27. So we can replace 3 square plus x plus 1 as the power. Now it's look like more easier now to solve. If you notice, we have the same base round, so we can apply the multiplication law of indices here. It says that when you have the same base, let's say a raised to the power m times a raised to the power n, you have the same base multiplying each other. You only pick only one, then you add the power, which is m plus n. We have to apply this law here. Now, if you notice, we have the same base, so we only pick one. If we are picking 3, then we can add the power. You have x plus. Now, before we do that, let's simplify this power. Let's simplify the power. So we come here, 3x. So we have 3. 2 times x, we have 2x, minus 2 times 1, we have 2. So here we have 3. 3 times x, we have 3x, plus 3 times 1, we have 3. So it look more easier now. So we can apply the law now. The same base, we will only pick 1. Then we add the power, s plus 2s minus 2 over, we have 3s plus 2. So it look more easier now. Then we come here. If we are adding the power, let's say we have 3 here. Now, we have 3 here. X plus 2x, we have 3x, minus 2 is here, everything over 3x plus 2. Now, see again, we can use what? Division law to solve this one of indices. They have the same base, so we only pick one. We are picking only 3, then we can subtract the power, because the law says that if you have a raised to the power m times a raised to the power n, we pick only one base, which is a, then we subtract the power divide, so m minus what? N. So we can apply this law here. So the same base, we pick only one, then we subtract the power. So here we have 3x minus 2 minus this one. Please put brackets. If you do not put brackets, you really miss the question because of the sign. So 3x plus 2. So let's simplify. We have 3x minus 2. Minus times plus, we have minus 3x. Minus times plus, we have what? Minus what? Minus 2. So let's correlate terms here. We have 3. We have 3x come like this minus 3x minus 2. Sorry, minus 2. Then okay, I think okay. Sorry, if you notice here is 3. A mistake. So you're supposed to be 3. You're supposed to be 3. Sorry, you're supposed to be 3. So minus 2, then minus 3. Plus 3s minus 3s cancel each other. We have 3 left. So we have minus 2 minus 3, that's minus 5. Now we can use a law called the negative law of indices. So if we want to solve that, just look for the inverse. Inverse means that this minus here will change to 1 over. Then you now bring the base and the power together. Then the base is 3, the power is 5. So if you solve, we have 1 over. Now 3 in 5 places. 3 times 3 times 3 times 3 times 3. I think is 243. So this is the first question we will look at under the indices. Please, if you have not watched my video on the law of indices, please go back to part 1 of this video and go and watch the video, please, because I will be trying to applying the law when I'm solving question under indices here. So this is the first question. Let's see another question. Let's see another question. Second question, I think I have here is 3. Okay, let's see the question. 125 m minus 3. Okay, everything is in brackets. Sorry, there's a bracket here. 1 over 2. So I think this is the question. Let's see. Now you can solve this one in two ways. Let me check this marker. You can solve it in what? In 2 ways. Number 1 is either you this cube root here, you change it to 1 over 3, because in mathematics, if you have something like this, a square, to give you 4 number 1 over 2. These two, they are the same thing. Are you with me now? If you have 4th root of 5, it will give you 5 1 over 4. These two, they are the same thing. So we did not change anything. So we can change this cube root back to 1 over 3, or we solve this one first, then later we can now change it. Anyone you do, you will still get the same answer. So just the basic thing is the concept. Once you can get the concept, you are free to what? You are free to go. So here I'm solving this middle part first, then I'll bring it out. I'm having 1 2 5 m minus 3, everything is power minus 2. Now we have a law under indices, and the product power law. It says that if a variable, let's say we have x is multiplying y multiplying z raised to power m, we should assign the power to each variable. So we have s raised to power m times y raised to power m times z raised to power m. So we can have x m y m z what m. So this is the law. So let's apply this law here. 125 is multiplying m raised to power minus 3. So let's assign the power to them. So 125, we carry 1 over 2. M minus 3, we also carry 1 over 2. This thing here is multiplication sign. So here now, I think it's looking more easier now. So we can move the brackets here. So we have only 1 over 2, 125 is to power 1 over 2 here. Then here times here. Now this is law of indices again. Go back to my video and go and watch it. I said if you have a raised to power m raised to power n, To solve this one, just multiply the power. So we have a is to power m times n, a is to power m n. So all these laws, they are very, very important. So you need to what? You need to know all these laws, because if you are solving any question under indices without knowing the law of indices, you really have problem. So now we can apply this law, multiply the powers. So we are timesing the powers. So here we have m, that's minus 3 times 1 over 2. So here now, I think you have 125 times m minus 3 times 1. You have minus 3 over 2. So we have simplified this one here to get this one. Then we can now put our cube root back. Our cube root back. Sorry, 1 over 2 supposed to be here. Then we can add our cube root. Now, this is our cube root. Now we can now change it back. Then everything will be in the brackets. 125 1 over 2 times m minus 3 over 2, everything in bracket. Then it's not changed, 1 over 3. Indices looking more interested. I love that. So here now we can assign the power to each variables. So here we have 125 1 over 2 times 1 over 3 multiplied by m minus 3 over 2 multiplied by 1 over 3. So here now let's multiply. We have 1, 2, 5. 1 times 1, 1. 2 times 3, we have 6 times m here. 3 3 cancel 3 here. So we have 1 left. So we have minus 1 over 2. Looking more interesting. Here now we can break this 125 down. If you say 5 times 5 times 5, I think it's 125. So that's 5 to the power 3. We can change this one to 5 to the power 3. So if you are solving any question on indices, please try to break the base, as in try to break your number down into base, into something like this. It will look more easier for you. So so change this one. We have 5 5 to the power 3 here times 1 over 6. Then times m minus 1 over 2. So 3 here 1, 3 here 2. We are left with 5 over 1 over 2 times m minus 1 over 2. Looking more interesting. Let's solve this part because of this minus. So we have 5 1 over 2 times, now this negative sign will not change to 1 over m 1 over 2 here. Looking more interesting. 2 over 1 to balance the equation. Now 5 1 over 2 here times 1 will give us what? 5 number 1 5 raised to the power what? 1 over 2 here over, we have m raised to the power 1 over 2. If you notice that they have the same word, the same power, so we can just give them just one word, one power. We can say 5 over m, everything in brackets, 1 over 2. We are still saying the same thing because this 5 is the owner of this one, m is the owner of this one, so it's still balanced. So we can now change this one back to square root. So you can say square root 5 over m. We are not changing anything, it's mathematics. So this is the final answer. So this one here, either way, we are still saying the same thing. So this is the final word answer. So this is the second question we are looking at under indices. Now the third question. Moving to the third question. Please go to my video, the part 1 of this indices. Watch my video on the laws of indices, please, because if you don't have the concept of the law of indices, you will find it difficult to solve question under indices. Now the third question says that 3y 1 over 2 like this, so 3 over 2. So let's see 3 is multiplying y, if you see here. So we have two variables here. We can assign this power to the 2. So we can say 3, 1 over 2 times, we can say y, 1 over 2. Are you graphing? So here now we can say 3 again, 3 over 2 times y2 times what? 3 over 2. So here now we can just say, here now we can say 2 cancel 2. So here we have 3 whole number 1 over 2, y whole number 1 over 2, 3 whole number 3 over 2, then y is to power what? Is to power 3. Now we see here that we have 3 here, we have 3 here, there is multiplication. So we can use what? The multiplication law of indices, which states that if you have the same base, only pick one. So we are going to pick one out of these two. We are picking 3, then we add the power. So we are adding 1 over 2 plus 3 over 2 here times c, the same base, we only pick one, y, we add the power 1 over 2 plus 3, 2 over 1 to make it balance. So it look more easier now. So let's solve. Pick only one. They have the same denominator, just add the numerator. If you add, you have 4. 1 plus 3, you have 4. So you have 4 now. Okay, let me solve it here so you can see what I'm doing. 1 over 2 plus 3 over 4. So we have 3 over 2. LCM will give you what? 2. 2 into 1, 1 times 2, we have 2. 2 into 1, 1 times 3. Sorry. 2 into 1, 1 times, sorry. 2 into 1 times 1, we have 1. 2 into 1 times 3, we have 3. So 1 plus 3, we have 4 over 2. I'm not 2 can anything in 4, that's 2. So 3 goes to power 2. We're done with this side. It look more interesting, right? So let's solve this one. Why? So let's solve. 1 over 2 plus 3 over 1. The same to pick only 1. So LCM of 2 and 1 is what? 2. 2 into 1, 1 times 1, 1. 1 into 2, 2 times 3, you have 6. So you have 7 over 2. So you have 7 over 2 here. Now 3 square will give us what? 9 times y 7 2. So if you put together, you have 9 whole number raised to power 7 over 2. So it look more interesting like this. So this is the third question we are looking at under indices. So the fourth question, please, I'm saying it again, go back to the law of indices I made my first video. Please go and watch the law of indices, then you can now come back and watch this part 2. So it will look more easier for you. Then number 4, the fourth question, it says that 81 raised to power 1.5. Now, when I was treating my law of indices, I did not give you any law that has the power of like a decimal number as power. No. So we only have a fractional law, which is, let me say, a raised to power m over n. Fractional word power like this. So we can change this 1.5 to fraction. You know, if you say 15, you have 15 here, 15 over, we have 2 number here, 10. If it's 3 number, it's 100. 4 number, 1000. So that's the trick. We have just 2 numbers, so it's 10. How many zeros do you have here? 1. If you move one place, that's 1.5. So this one and this one, they are the same thing. So change it, this one, to this form. So we have 81, 15 over what? Over 10. So we can break it down. How many 3 can we see in 15? 5, sorry, 3. 5 in 10, we have 2. So we have 81 raised to power 3 over 2. Now this is fractional law now. So how can we solve it? The law says that if you have something like this, a raised to power m over n. This one here should come forward. So we have n, then the root of this base, everything over the numerator, which is m. So let's apply the same law here. These two will come like this, the root, then 81, then everything will come as 3. Now we'll look for, this is square, as in square root. So look for the square root of 81, which is what? 9 raised to power what? 3. So that's 9 times 9 times 9. 9 times 9 81. 81 times 9, 9 times 1, 9, 9 times 9 times 8, I think you have 72. So answer is 729. So this is the fourth question under indices. Please like, comment, subscribe to my channel. I'm doing more videos on differentiation, integration, APGP, and so on and so forth. So please subscribe, comment, and what, and like if this video really help you in any way. So the fifth question now. The fifth question. I think I have 0.25 raised to power minus half. Now here, very easy here. If you are having any decimal number when solving indices, please change it to fraction. So that it will look more easier to solve. So here now, when I say we are having three number, 1, 2, 3 is 100. Then we have 25 here. Change it to 25 over 100. See now, they are the same thing. We have 2 0 here. If you move 2 times 1, 2, your point will be here. Then add 1 0. 1 over 2. So here now we can solve. We can just eliminate the this negative sign here. So you look for the inverse to eliminate it. So we have 1 over 25 over 100. Everything should be what? 1 over 2. Now look more interesting now. So here we can this half, change it back to square root. So we have 1 over the square root of 25 and 100. So we're having 1 over square root will give you what? Here will give you 5. Here will give you what? 10. So here we are saying that 1 over 5 divided by what? 10 by 10. So we can change it to 1 over 5 times reciprocal 1 over 10. So we'll be having 1 over 50 as our answer. Very simple and straightforward. So this is my fifth question under indices. So let's look at the sixth question. So which is the last question. Let's see, we have x is to power 2 minus y is to power minus 3 minus 1, y is to power 2. So here now we can just change, this is square, which is 2 is here, so we can change it back first. So let's change it back. So we have here now, we have s is to power 2 minus y is to power minus 3, everything in bracket. So this 3 will now give us 1 over 3 over, look more easier now. So here let's change this one to x minus 1, y2, everything is what? 1 over 2, because this is square. Square root. Now here now, just assign the power to each variables. So we're having x2 times 1 over 3 minus y times 1 over 3, everything over this one to assign the power s1 times 1 over 2 y squared times 1 over 2. So 2 cancel 2, 3 cancel 3, which one again? So let's just, I think nothing again, so let's just times. So here we are having x 2 times 1, here will give us 2 over 3. 2 over 3. So I think I will have minus here or plus, so that I will not make mistake. So I think, let me check the question well. So I think no sign here. I think no sign here. No sign here. So no sign here. So it has to be times multiplication. Sorry, multiplication. So here now you have times y. So 3 cancel 3. You have only here 2. We have s 1. You have minus 1 because if you times here over what? Minus 1 over 2. times, you have y just 1. So see now, 2 over 3 in fraction, something in fraction, so to make it balance. Now, division law of indices is dividing. So let's just pick one out of the base. We are picking x. We are saying 2 over 3 divided by x whole number, x is to the power minus 1 over 2. So times y minus 1 over 1 divided by y 1 over 1. So look more easier now. Pick only 1. So we have x. So pick only 1 here. They will minus the power 2 over 3 minus, there's minus here already, full bracket, so that it will not affect what we are solving. 1 over 2 times y. So minus 1 over 1 minus 1 over 1. So let's solve. X 2 over 3 minus times minus will give us what? Plus 1 over 2 times y. So let's solve this one. If you have minus 1, LCM is 1. 1 in 1, 1 times minus 1. So you have minus 1. 1 in 1, 1 times minus 1, you have what? Minus 1. So everything will give us what? Minus 2. So we have minus 2 here. We have minus 2 here. So let's solve this one here. If we solve this one, we have 2 over 3 plus 1 over 2. LCM is what? 6. 3 in 6, 2 times 2, 4. 2 in 6, 3. 3 times 1, 3. So we have 7 over 6. So it's going to give us 7 over 6. So you have x 7 over 6 minus 7 over 2. So here now, we have x over 6 times 1 over 2. So are you seeing the board? So over 1. So it look more easier now. I think it look more easier now. So let's times x whole number 7 over 6 times 1 will give us what? X whole number 7 over 6. 1 times 1 will give us a y is the power what? 2. So this is the answer to this what question. Please like, comment, and subscribe to my video. If you have not watched the part 1, please go back and watch the part 1. Like, comment, and subscribe. Thank you. I really appreciate it. Have a nice day.